William, I sat and listened to everything that you explained to me about these three items. You know, we have an inverter, we have a charger, we have a transfer switch. I can't see with today's technology any reason to use these three items anymore when everything is built in right here.
Very true.
Let's put this thing in and show them just how well it works.
I'm ready. Let's
okay.
Go. We now got our panel pulled off. We've got all of our wires pulled out that we're going to need to do the installation. And as usual, like I said earlier, you never know what you're going to run into. Originally, when this ambulance was built, it did have some type of larger inverter involved. And whether through failure or just through change of ownership in companies, somehow this thing has ended up with a small, what we like to call the truck stop style inverter. Doesn't even work anymore, doesn't even come on. It just kind of shows you how unreliable some of these products can be. So it's really important, especially in an ambulance with such high demands, that they run a quality piece of equipment. So what we're going to do is we're going to go ahead and finish getting this inverter removed. Once that's done, I need to do a little prep on the leads. We'll get the new inverter set in, make our connections, go ahead and mount it, run a remote cable, and that'll give us the ability then at that point in time to go ahead and do a preliminary test on operation. All right, we've pretty much got everything prepped to go ahead and start making our connections on the HF 1800 EMS. First thing we need to go ahead and do is hook up our battery cables. Now normally the EMS unit does come pre-set up with DC cables. However, in this ambulance they had already cut the ends off, so we had to go ahead and put in our own regular connector ends. That way we can make our attachments to the inverter. So we're going to go ahead and start with the ground cable first. It's also a good idea during the installation, once you've completed it and you're ready to do your initial test, you want to make sure you got good, fresh batteries on the vehicle. This situation, we have replaced all 4 of the batteries that are available in this ambulance, so we're going to start off with nice, fresh, clean power. Now we're going to go ahead and hook up our 12-volt cable. All right, we've got our DC cables hooked up. Now we're going to go ahead and move into our other cables. This is our AC in. We've talked about it previously in the video. We're going to go ahead and connect that to our shoreline output, which is right here. So they basically just plug into each other. This is coming from the exterior outlet, input outlet on the outside of the vehicle that you'd plug your shore cord into. We'll make our connection there. We then get us a little bit more room, start setting this in to mount. This is our AC output. This right here is our AC input to the vehicle. This is going to feed all the outlets that are located throughout the cabin of the ambulance. Once we've made that connection, we're in pretty good shape. I'm going to go ahead and take our communication cable, which is going to feed up to the remote, make that connection. In this application, the customers chose not to hook up the ignition lockout. They already have a policy and procedure that when the ambulances are not being run or used, they park them and they plug them into shoreline. At that point, the internal AC switching device kicks in. It goes ahead, starts charging the batteries, and then just basically allows the AC coming in from the shoreline through this cable to pass through the AC switching and right back out to the shoreline. So at this point in time, the inverter is not supplying any AC power to the vehicle. The only thing it's doing is using its battery charger features to go ahead and charge the batteries on the chassis. Alright, we've made all of our AC-DC connections. We've gone ahead and we've mounted the inverter in the compartment as discussed earlier. We've got our communication cable run up. We've made our trim plate for our controller. We're ready to go ahead and do our installation or connect it, making our final connections before we can go ahead and test. Okay, our control panel is now up. It does show 12.4 input voltage. We are kicked on. We are in invert mode. Our battery status, a little amber light is showing we got green, yellow, or red. Green being utility, B being battery, red being fault. Right now we're on battery mode for invert. Our outlets are hot. We'll go ahead and plug in to make sure we've got everything connected. Now that we've been testing our inverter charger, we're going to go ahead and run through some of the basic functions before we go into a charging test. As you can see, we have the inverter powered up. We do have it in operation mode, again showing our input voltage. We're going to go ahead and check our input current. Since we are not plugged in at this point, we're going to have 0 input current. Our output power in kilowatts, since there's nothing plugged in operating at the moment, it is showing 0. Say we were to plug in, say, a heart monitor, a fan, a battery charger for us, monitoring device or anything like that, we would be reading in output wattage. Again, this is an 1800 watt continuous output with up to 3600 surge. In our initiation 1, we're all good there. We are a 40 amp charging capability. All the rest of the features are preset for original standard. So at this point we don't need to make any adjustments. We're not using this for any modified application. Alright, we've checked our DC operational controls on the HF control panel. We've now gone ahead and plugged into Shoreline. It is reading that it is in a bulk charge mode. Our LED is flashing green. If it were in absorption mode, it would be saying ABS and flashing green. If the battery charge is completely full, your green light's going to be solid green, and it would be in float. So at this point in time, we know that our AC input is working fine. Our pass-through, if we take our circuit tester and plug in, we're getting our 2 yellow lights showing that our pass-through operation for AC is operational and correct wiring as well. So at this point in time, this completes the installation and basic testing of the Freedom HF 1800 EMS model on the installation here in this ambulance.